Okay, so this is just a very quick demonstration of what you can do with TOPCAT. So I've taken a VO table that I extracted from Vizier. These are objects within 5 degrees of the centre of the Pleiades. So some of these should hopefully be cluster members, and I'm going to try and explore that using TOPCAT. Okay, so if we look at the table we've got, you can see we've got distance from the cluster centre, a couple of positions, some Tycho numbers, some proper motions, and some photometry. But let's say I wanted a bit more photometry. So I could query against some catalogues using TOPCAT, and let's look at the 2MAS catalogue. So let's look up the registry to find the 2MAS catalogue. And while it's doing that, I shall open up the correct table. I'm going to go for 6 arc seconds, I reckon. Okay, and I tend to prefer using Vizier for some reason. I'm not quite sure why. And we'll just have an output table with 1 row per input because we don't want to lose a star because there's not a good 2MAS match. So that is churning away, and it'll take a minute or two. I'll just quickly show you a couple of other things with TOPCAT. For example, there are functions. You can do things. The one I use the most is the coordinates function for doing things like converting sexagesimal coordinates into radians, and that's quite useful because if you load up a table that's got sexagesimal coordinates from a paper or something like that, you can convert it into radians, and then you can maybe use this tool here, which can match the tables from some paper with some of your data to stuff like searching against not just positions on the sky, but positions on the sky with distances, hierarchical triangular meshes within 3D Cartesian space, for instance, anything like that. And nice little plot to show you where our objects lie in the sky. There we go, that's where you'd expect the Pleiades to lie, so we're not doing too badly. This is only really useful for sky positions, but it's kind of nice to fiddle about with. So we're almost finished with the 2MAS cross query, and that was 3,500 objects done in a minute or two maybe. Okay, so let's have a look at this table. Here we've got positions, magnitudes, proper motions like before, but stuck on the end are the 2MAS astrometry and photometry. You can see we've got the magnitudes here, quality flags, things like that. Now let's have a look at our data, because the Pleiades moves through space at the same velocity, common velocity, so you kind of expect all the objects to have the same proper motion. So we can maybe select some candidates out by proper motion. So there's the 2 proper motions plotted against each other. Zoom in a bit, and you can see here, that I think is the field distribution of proper motions. And I'm going to claim that this is the Pleiades, so let's zoom in. Okay, zoom in a bit more. Now, let me select out all these objects by clicking on this and drawing around them. So I'm going to call these Pleiades members. Very optimistically, but let's see. Okay, and if I want to have a complementary subset to that, I can click on subsets, select my member subset, and create a complementary subset called not members. Okay, so we've got what we think are members. Let's have a look at some color magnitude diagrams. So as well as having the columns we define in this table, we can create new columns. Let's call this one BV, and we'll make it the B magnitude minus the V magnitude, oddly enough. And since we've got the 2MAS photometry, let's have VK as well. So that's V minus K. Okay, and let's plot a color magnitude diagram. And we want for the x-axis B minus V, and for the y-axis, let's say V. And we'll flip that y-axis. Okay, so this is all the objects. Let's plot the non-members only. And I don't like that colour, so I'll just change that to that. And we'll add on the members on top of that, and you'll see why I made this a lighter colour, because it makes the members stand out more. And you can see we've got a very nice cluster sequence, and then it kind of gets a bit ratty down here with the photometry gets a bit worse. I can also do that with V minus K, and you can see our cluster sequence is even nicer and tighter than before. If you wanted to do, for some reason you wanted to plot two colours against the magnitude at the same time, you can use the 3D plot. So you would use B minus V, V minus K, and then the magnitude would be, let's say, V band, so that's B band, V band there, and let's just make it the members only, flip that, and you can see there are members snaking their way through colour magnitude space. You can also look at column statistics using this tool here. Let's just look at our members, and we have a spread of proper motions of about 2 milliarc seconds a year. And if we look here, then our proper motion errors are of the order of 1 or 2 milliarc seconds a year. So this is, you know, fairly consistent with the errors in the proper motions. And just finally, to plot a sort of poor man's luminosity function, we can look at a histogram. We'll do a histogram against V-band magnitude, and let's just do it for the members. To change that scale, and maybe bin it a bit more coarsely. Not that coarsely, that coarsely. There you go. So there's a very rough V-band luminosity function for the Pleiades that took, what, 3 or 4 minutes, something like that, just using TOPCAT. So yeah.